Hello everyone, in this video we are going to see about the multiplexer and demultiplexer. Let us see what is a multiplexer first. Multiplexer means many to one. That means we are choosing one from many. Okay. So a multiplexer is a circuit used to select and route any one of the several input signals to a single output. That means we have so many input signals. From there we can choose one and we pass it as an output. That is, from many we are passing it a single one. Multiplexers can handle two types of data, both analog and digital. For analog application, multiplexer are built using relays and transistor switches. But in the case of digital applications, they are built from the standard logic gates. That means we can build the multiplexer using the basic normal gates like AND, OR, NOT, etc. This is a block diagram of multiplexer. So you can see here there are several input lines. So we can see here this is the several input lines are here. From this input lines we are using we are selecting one output signal based upon the control line. So here we have M control lines and N input signals. This multiplexer is a combinational circuit that selects one among the input signal and pass it as an output. This is the block diagram. Let us say the logical circuit of 4x1 multiplexer. So what is 4x1 means? Among the 4 inputs it chooses one output. That is called as an 4x1 multiplexer. So we know that for 4 combinations, that means for 4 combinations we should have 2 variables. Okay, so here 0, 1, 2, 3 are the 4 combinations. So these 4 combinations are got from the 2 inputs. As we know, 2 power n is the possible number of combinations. So we are having 2 variables A and B to give all the 4 combinations. So what are the 4 combinations? A is 0 and B is 0, and then 0, 1, 1, 0 and 1, 1. So accordingly we can see here there is a normal variable and this is a complement variable. From this is input A and this is A bar, and this is input B and this is input B bar. Okay, so here we know that based upon the input lines and the possible combinations, the control lines, the output will be generated. So how it is generated? We are having 4 gates, 0, 1, 2, 3. So all the 4 AND gates process the input from A or A bar depending upon the control logic, and that output will be passed as the input to the OR gate. This OR gate will add all the outputs from the 4 AND gates and it pass it as a single output. This is the logic circuit of 4x1 multiplexer. Okay, so here this is first one is 0, 0. So this combination is an A bar and this is B bar. So first gate contains the A bar, B bar and the control signal from the D0. Okay, likewise this is A bar and B, and that is the gate 1 and the control signal from gate 1, and this is A is 1 and B is 0. So 1, 0, the second gate is enabled, and then that is from the control signal D2, and the last combination 1, 1 where both A and B comes from the line 1, and then the control signal D3 all pass to the AND gate. Okay, so these AND gates produce the output based upon the input that is given to the AND gate, and we know that when all the inputs are 1, then only the AND gate generates high input. So accordingly, based upon the combination and the control signal, the AND gates passes the output as an input to the OR gate, and that OR gate combines all the perform the logical OR of the inputs from the which is the output of the AND gates. Okay, so this is how the multiplexer works. So based upon the control signal as well as the input signal, this multiplexer processes the data and it produces a single output. Okay, let us see what are the applications of multiplexer. Multiplexer are used in various fields where multiple data need to be transmitted using a single line. Following are some of the applications of multiplexers. So they are used in the communication system and they are used in the telephone networks. So they are also communication system, and it is also used in the computer memory where data has to be passed from many lines to one line, and the transmission from the computer system of a satellite. Okay, so anywhere it is also all about the communications, either within the computer or outside the computer or within the telephone or any. So totally this communication system uses the multiplexer logic. Let us see what is demultiplexer. This is the block diagram. So as the name implies, it demultiplex means is the opposite function of multiplexer. So one input signal is propagated into many output signal. That is the purpose of demultiplexer. That too works on the basis of the control lines. Okay, so this is the function. Demultiplexer means one to many. A demultiplexer is a circuit with one input and many outputs. By applying control signals, we can steer any input into the output. There are a few types of demultiplexer: 1 to 2, 1 to 4, 1 to 8 and 1 to 16 demultiplexer. So these lines 2, 4, 8, 16 are the control lines or the select lines. These select lines is based upon the number of lines that being used. Okay. This figure illustrates the 1 to 4 because they are having one input and 4 output signal. Okay. Generally it is given as M and N. So actually this is line 1, 2, 3 etc. up to M. So this is a control. M control lines are there and one input signal is passed as several M output signal. Okay, this is a example of a general multiplexer having M control lines demultiplexing one signal into multiple M signals. Okay, let us see the gate diagram of this demultiplexer. So this control, the block diagram of the demultiplexer is expanded using the logical circuit. So we have one input and 4 outputs. Okay, so the one input is the data input, and based upon the combination of this control signals A and B, the data is multiplexed to the different lines 1, 2, 3 and 4. So as we know, we are having for the 4 combinations we need 2 variables A and B. So A is in the normal form, A is in the complement form, likewise B in the normal form, B is the complement form, and the combinations of 0, 0, 0, 1, 1, 0 and 1, 1 are taken as the input for these AND gates. 1, 2, 3 and 4 AND gates are there. So each AND gate produces one output based upon the input as well as the control signal that comes from A and B. Okay, so this is how the demultiplexer logic works. What are the applications of demultiplexer? It is also used in the communication system and it is used in the arithmetic logical unit. So we know that inside the arithmetic logic unit, the data has to be passed from one input to many output lines. So for that we are using the demultiplexer. So it converts the serial to the parallel converter. It acts as the converter between the serial data to the parallel data. And let us see the difference of multiplexer and demultiplexer. So we know that multiplexer processes the digital data from various sources into a single line, and demultiplexer from single source to several output sources. Multiplexer is a data selector because it selects one from many, and demultiplexer is a data distributor because one data is passed to many lines. It's a distributor. Okay, and then multiplexer is a digital switch because it switches from many to one, whereas demultiplexer is a digital circuit. So actually switch changes from one position to the other position. Okay, it's toggling, but demultiplexer is a circuit. It follows the combination logic type. It also follows the combination logic type. And then few more differences. The fifth difference is it has n input data, it has single data input, and it has single data output, it has n data outputs, and then it works on many to one principle and it works on one to many principle. And then finally time division multiplexing, it it is used at the transmitter end. In the case of demultiplexer, it is used at the receiving end, because we know that multiplexer and demultiplexer are used in the communication system. So from the sending side or the transmitting side, multiplexers are used. The receiving side, demultiplexers are used. Okay, so that's all the differences between the multiplexer and demultiplexer. Hope it is easy to follow, and thanks for watching.